Okay, now we're going to look at something called the standard deviation. Alright, okay, so before we get into the calculation of working out the standard deviation, I just want to talk about what this actually means, okay? Because I've taught lots of students who could do awful lot of calculations to work out the standard deviation, change it around, but they never quite understand, in a sense, what standard deviation means. Okay, they never quite grasp it. Okay, I really want you to grasp what the standard deviation of a particular data set is. Okay, you get a feel for it. Okay, so to really know it within you, what it really means. Okay, not just the number. Okay, right, now to do that, all right, now let's just say you finish university and you've gone to the graduate fair, all right, and you're meeting potential employers, okay, and you meet someone there and they say, oh, in this company I earn this much for a month. Okay, on 1 month I earn 2000, the other month I earn 1800, the other month I earn 1700, the other month I earn 2300, and the other month I earn 2200. Okay, I can see that the mean is, if I add these all up, I have 10,000, okay, divided by 5, which is 2000. Okay, that's the mean. All right, so the mean is 2000 here. All right, so you go and ask somebody from company A, then you ask from somebody company B, what do you earn, what have you been earning for the last 5 months? Okay, now they say they earn 1200, 1300, 2800, 2700, and 2000. Okay, this is what they earn. All right, now here again, if you add these values all up, you get 10,000 for the 5 months, and you divide it by 5, you get 2000 as mean. Okay, now you got means that are the same. All right, but there is some property, some characteristic of this data that is different. Okay, so you can't say, okay, I can't really pick between company A and B because blokes from both those companies earn the same mean salary. All right, now if you notice with this one though, there is a large amount of variability. All right, compared to this. Okay, because in a given month you're earning sometimes at 1200, sometimes you're earning 2800. Okay, this is probably like a commission based job, okay, where you get a base salary plus you get some commission. This probably is a job where you just get paid overtime if you work extra, so that's when you get 2300. Sometimes if you don't come to work, you get this. All right, here probably this is a commission based job. All right, so there's a large amount of variability. Okay, now the standard deviation is basically the average deviation of each of these points from the mean. Okay, it's sort of like the average deviation of each of these points from the mean. Okay, so the average, so the deviation between 2000 and 2000, this is minus 200, this is minus 300, 300, this is 200. Okay, now the problem is if you add all of this up, you get 0, for the deviation. Okay, so what we do is we just consider the we disregard the negative sign, so we get 1000. Okay, so 1000 is a deviation. You divide that by 5, you got 5 points there. 2000 is also considered, so the average deviation is 200. Okay, for this though, it's 800 here, minus 800, minus 700, 800 positive, this is positive 700, and 0 there. Here the deviation is 3000. If I add all of these up and I divide that by 5, so the average deviation is 500. Okay, oops, no, it's not 500, that's 600. Okay, 3000 divided by 5 is 600. Okay, so the standard deviation, okay, is slightly different to this value, if you, okay, but it's something like this. Okay, it's probably something very close to 200. Okay, but this is in a sense what the standard deviation is. Okay, it's like the average deviation of each data point from the mean. Okay, so that's what you calculate when you figure out the standard deviation. Okay, so for these two jobs, not only will you have to compare the mean, you have to compare the standard deviation as well. Okay, if the mean is exactly the same, you might as well go for the one that has the lowest standard deviation or the lower variation, because you'd rather be, you know, certain as to what you're getting more or less each month. Okay, you're going to get more or less 2000. Than with this, where there is a large amount of variability. On average, over a 5-month period, you probably earn 2000, but there's a large amount of variability, so it's going to help. It's going to be a bit difficult to manage your cash flow here. Okay, so you'd go for this one. Okay, even though the means are the same. All right, so that's what the standard deviation is. Okay, now I'm going to look at the precise way of calculating the standard deviation. Okay, that value there, which was 200, right here, it is a bit of a rough value. Okay, I'm going to look at the precise way of calculating the standard deviation. Okay, so I've listed out each of those values there for company A. All right, and I'm taking this value away from the mean. Okay, x bar is the mean. Okay, so x is the value here, so that's 2000 minus 2000 is 0. 2000 minus, sorry, 1800 minus 2000 is minus 200. So I'm doing that for each of these. All right, and then what I'm doing is I'm squaring it. All right, okay, so that the minus values don't affect the doesn't affect the data. All right, it doesn't cancel out the positive values. So I'm squaring it. It's 4000, and then I'm adding it. All right, so that's 8000 plus 18,000. That's 8,000 plus 18,000 is 26,000. Okay, now this result, what I'm going to do, because I've squared values, I've got to divide this by 5, because I have 5 categories. Okay, 5 data points. Okay, and then I've got to square root that answer. Okay, I beg your pardon, I made a small error here. When I squared minus 200, it should have been 40,000. When I squared minus 300, it should have been 90,000. So an extra 0 there. Alright, so an extra 0 here. Alright, so I divide all of this by 5, and then that result, which is 5,200, no, 52,000. That result I get the square root of. I get 228. Okay, as my standard deviation, which is awfully close to 200. Okay, so that's my precise value for my standard deviation. Okay, right, so the standard formula for this to work out the standard deviation is this. It's x minus x bar, whole thing squared. Okay, sum of, so you're adding each of the differences from the mean, the squared ones. Okay, and you're going to divide that by the sum of frequency. Okay, total number of points. Okay, or I should say, for in this instance, because there is no, it's not a frequency table, I should just say that's n. Okay, and that whole result is square rooted. Okay, right, now in the exam though, you got to use a different formula. You got to use this formula. You got to use the mean squared is taken away from each of the points squared divided by n. Okay, which is actually exactly the same thing what we've done here. It's just that when you rearrange it, it could be written like this as well. Okay, so in the exam you have to use this. You can use this as well. This is better to illustrate how the standard deviation is calculated. Exact same value you would get if you use this formula. So if I were to follow this method, this is what I do. I square each of my points, okay, and I get this result. Okay, so that's 202,640 divided by 5. I divide it by 5, and then that value I take it from my mean squared, take it away from my mean squared, which is 2000 squared. Okay, so I end up with my same answer here, 52,000 square root. So that is should be equal to 228, similar to the answer that I've got above. Alright, because I ended up with the 52,000 there as well. Okay, so you'll have to use, you could use this formula or this formula, but this is a bit simpler, few calculations, few steps than this one here. Alright, okay. You'll be also asked to work out the standard deviation for frequency tables. Okay, So you have a value of 115, 125, 135, 145. 4 people have a value of this, 5 people have a value of this, 3 have this, and 2 have this. Alright, you'll have to work out these intermediate values for a frequency table, okay, to work out its standard deviation. Right, you need to work, this is the formula, okay, to work out the standard deviation. You need the sum of fx squared, okay. You need to do the x squared first and then times it by frequency, okay. It's not doing fx first and then squaring the whole thing. You gotta do x squared first and then times it by the frequency, okay. So you'll also have to work out f of x, because you need to work out the mean, because there's a mean squared here. So the mean is basically, I've gone through this with you 2 videos back, or in chapter 2 videos, that sum of fx divided by sum of f, okay. So let's first work out what the mean is, okay. I'll fill out the values here, okay. When I fill out these, I get all of these values, and when I add them all up, my sum of fx is 1780, okay. Now I will have to do fx squared, so I'll have to square my x and then multiply it by f, okay. But I don't need to do that all over again. I have fx here, so this value just needs to get multiplied by another 115, okay. That way I get my x squared, and then that being times by my f. So all what I have to do is times this with this, okay, to get my fx squared, okay. So that's, I'll do the first one for you. 460 times 115, which is 52,900. So similarly, I do this times this to get my f times x squared, okay. Okay, so I get these values, then I add them all up and I get this. So my mean would be, now for my mean I don't need to worry about this. I divide this by my sum of f, which is 14. Add these all up, I get 14, yes, okay. So 1780 divided by 14. Okay, so I get that answer there. Alright, now usually in exams they ask you to give answers to 2 decimal places. So I strongly suggest the intermediate values that you do here, you get that to 3 decimal places, so you don't lose any, you don't get an inaccurate answer because you've truncated your answer too much, okay, you rounded it up too much. So that's 127.142 there, so I've got to square that, and I've got to also write my 227,750 there, that being divided by 14 again, okay. So if I work this one out, I'll get my standard deviation. Okay, so if I work that out, I get my standard deviation to be 10.14, okay. Okay, so that's how you work out the standard deviation for a frequency table. Alright, now you could get this table in a different format as well, where the frequency categories here could be grouped, okay. You could have a category that could take range of values, okay. Now this is what you do there. Okay, now you have a group frequency table here. Alright, so you have these categories, you've got to take its midpoint, okay, because you have 4 people in this category, but you just don't know whether the 4 of them had 110 or 120, so you go for a good estimate, which is the mid value, okay. So you say the 4 of them had 115, okay, and then you got to take the mid x point. So I mean, from that point onwards is exactly the same calculation. In fact, it's the same table there, and the same sort of values. Only thing, I've just created the category, a group frequency table, where the midpoint would be these values here. So that's why I considered 110 to 120. So the midpoint would be 115, so I wouldn't have to redo another table, okay. So that's the only thing different here. If you had a group frequency table, you take the mid x value and the rest is the same, okay. So I hope you found that helpful. I'll see you again on my next video, so good luck. Bye bye.